So what is a memory map and why do we need it? Well, if we drop down into our computer, we're going to have a ROM and a RAM. Now we have a 16-bit machine, so we'll get 2 to the power of 16 possible memory locations. And we've got those split equally between the ROM and the RAM. So if we drop into the ROM, you can see that we've got all of these individual memory locations available to us. So if we take just the very first one, for instance, this is the very first memory location, 0000. The next memory location is 0001 and 02, and so on and so forth. Now note that each of these memory locations is in effect 2 bytes, or 16 individual ones and zeros. So whenever we do our fetch execute cycle, in the fetch we grab 16 individual ones and zeros, or 2 bytes at a time. So you can see all of the information is going to exist, and look how much we've got available to us. Okay, so that's the first, if you like, 32 kilobytes. Now the other 32 kilobytes is available within the RAM, and again we've got all of this memory available to us. So we have to be careful about how we use this memory. We're going to have in the ROM, that is the read-only memory, our operating system. So for our machine, our operating system is all of our library files, which have all been concatenated together, and they've all been placed into this ROM, so that whenever we log out of Logisim and we log back in, all of that information is still available to us. So whenever we generate, for example, our floating point library, we're going to have the routines existing in a particular place in the memory within this ROM. And then if we generate our graphics library, it's going to exist in a different place within this ROM. And what we want to make sure is that whenever we generate these libraries, we don't have one library accidentally overwriting another library. Now another thing that we have to be careful is that within these libraries we're going to have subroutines, and these subroutines are in themselves going to use temporary memory locations. So the temporary memory locations these subroutines use aren't going to be in the ROM here, they're actually going to be in the RAM. So we need to know whereabouts in the RAM these temporary allocations for the subroutines that are in the ROM, we need to know where they are, and we need to be careful that we're not overwriting them while we're in the middle of a program. It's just going to mess everything up. So there's lots of these little subtle things that occur that tell us that we really need to be careful about where we put information in our ROM and our RAM. And this is the reason why we want to have a memory map. So here is our memory map for the RTM16. So we're going to have our starting address, and this represents the starting address of each of these library functions. Now I haven't put in the end address. What we can assume is that the end address is going to be one before the starting address of the next value. So we're going to potentially have lots of extra space available between one library and the next library, in order that if we decide to add any more subroutines, we've got space there to expand into. So on the second column here, we've got a description of what the libraries are, or what the space is used for, and then a little note here, just a description of it. So in the first column here, all of the ROM exists here within the first block, and then the RAM exists in the other two blocks here. So this is the ROM and this is the RAM. So these are the memory allocations for the ROM and the RAM, which we just looked at a second ago. So from position 0000 is going to be the BIOS. Okay, so that's our basic input-output system. So these are the subroutines we use for the keyboard and for the text display, so that we can enter information into the keyboard and we can print it on the text display. Now the next address here, this is the beginning of the mathematics library. So these are our integer routines, and then at 0 cross 2000 we've got our graphics library, 3000 is the string library, the fixed point library and the floating point library. So this makes up all of the libraries we have within our ROM. Now if we head on to the RAM, we're going to have the beginning of the RAM. So the beginning of the RAM is going to be 0 cross 8000. And the first address there, 0 cross 8000, is going to represent the beginning of our user code. That is our program. So we load our program in and it starts running at this location. Now we're also going to have the potential of having user data. So when we write a program, we're going to have some data available to us that we use within that program. So we're storing the data starting at 0 cross B000. Now as I mentioned earlier, whenever you're in the ROM and you have a subroutine in the ROM, you also have data and variables that are going to be part of that program within the ROM. But they're temporary and we don't want to actually write them within the ROM, we want to write them within the RAM. So we have this location here for the library data and subroutines, library data and variables, and it's at 0 cross C000. Now we have one position, so in effect this is just one single memory cell, and we'll use this for our trap address, and we can have a look at that just in a minute. Now we have another position here, 0 cross D000, and this is for something called the heap. We haven't talked about the heap within the course, but we can use this potentially for some dynamic memory allocation, and the heap works in the opposite sense to the stack. It's going to grow upwards. But we can have a talk about the heap potentially when we go on to design a CPU 5. Now the other positions here are for the stack, and the stack's going to be at the end of near the end of our RAM, and it's going to grow down the way, so it's going to grow towards the heap and the heap will grow up towards the stack, but of course we have to make sure that they don't overlap. And we've talked about the stack in several other videos within the Design a CPU series. Now finally, at the very end of our RAM, we have these allocations here. So the one is for, so they're in effect are the memory mapped I/O ports. So we've got the keyboard, we've got a spare 1 and 2, our display port and our graphics 1 and 2. And you can see all of these in effect within the motherboard of our computer. So that's a basic memory map and everything we really need to take care of. So let's have a wee look and we'll see where we can get this information actually within the libraries, and we can see these actual memory locations within the subroutines within the libraries. So if we head into the BIOS, in effect this is our first library, and you can see here that we've got the addresses for each of the subroutines. So we've got 1, 2, 3, 4, 5, 6 subroutines here within this BIOS. And you can see the very first one begins at 0x0100. So we can go in and have a little look at that within the machine. So that's going to be within the ROM. This is the ROM here. Now the very first 1, 2, 3, 4 values here, remember the first ones are used to set up the stack pointer, and then the next one's just a jump to address 8000. So it's saying jump to the address allocation 8000, which is this memory location here in the RAM, which is the first address of the program. So that's the very first thing that happens in our computer when we first start it up and we run a piece of code. It goes to this point, it sets up the stack, and then it jumps to this point here, and then it starts running the program from this point. Now, whenever we're running the program for this point here, we might have subroutines within we might have functions or subroutines within this program that we need to get access to. So we jump from here back into here. Now, if you look at here, we've got the 0x100. So this is the beginning of the BIOS functions. So this is the very first BIOS function here. And you can see that the second BIOS function, if we head in, is 0x0120. And there's the second BIOS function starting here. So this little block here is going to be our BIOS. And you can see that there's a lot of space then between the BIOS and the very next blocks. So all of this is spare positions that we can generate more BIOS functions. And you can see there's an awful lot of it. So next we head down into the beginning of the next block. So the next position here that we've got some information in is 0FF0. And this is the beginning of our mathematics library. So this is the integer maths library, and you can see we've got one subroutine here, and we've got a little gap, we've got another subroutine, and a little gap, and we've got another subroutine. And these are all the individual subroutines within that particular library. And you see them all here. And it's quite a big library, and it heads down to this point here. So this is the end of it, okay? And now we've got a gap between the next block. So the next block is 2000, okay? So 2000, if we head back in, 2000 is the beginning of the graphics library, okay? So this here is the routines within the graphics library, and we can actually get in to the graphics library and have a little look. So if we get into graphics and we head up to the top of the graphics library, we can see the first routine there is actually the graphics underscore line. So that's the drawing a line algorithm. And then we've got a rectangle, circle, triangle, plot, and floating point plot. And those all exist here within this area 2000. So that will be the last one here, and so on and so forth. Now, A thing to note here, if we look at the library here for the graphics library, if we head down to the bottom of it, we're going to have this .ram, and the .ram is, in this case here, says 0 cross C 080. So this position here is a position that's actually within the RAM. So this is the point where I said that within the subroutines here within the ROM, we're still going to generate potentially variables and also data. And we need a place to store those variables and the data within the variables. And this tells us here where we're going to store it. So this is where we have to be careful and understand where this information is going to be held. And you can see when we look at our little block here, it's quite rendered, right? But you can see here we've got the 0 cross C000. So this is the library data we're talking about. So the last part here are our memory mapped I/O ports. And you can see this starts at 0 cross FFF0, F1, 2, 3, and so on and so forth. So these here are nothing other than the port allocations that we have here for our keyboard, the spare, the display, the graphics 2 and the graphics 1. So whenever we try to access these memory locations, we're actually accessing those pieces of hardware within our motherboard. So we've seen that in a previous course. So that's the setup for our memory map. Now if you're looking for a copy of the memory map, you can get into the docs and you can get into guides, and you can see here we've got a memory map in PDF, so you can have a look at that, and it just follows what I've shown you on this video. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.